Hi all. Finland Azure User Group Virtual Azure Tips and Tricks Extravaganza to the Max 2020 is here. Welcome. FAUG is about continuous learning and the community around cloud computing and Microsoft Azure. We have over 1,600 members and we organize over 10 events yearly, virtually and in person, of which the largest example is IGLUCON, held every January. Virtual Azure Tips and Tricks is a year-long event during which we present several about 30-minute talks about various topics by various presenters. Please tune in to our meetup site to view the upcoming presentations and to our YouTube channel to view the previous presentations. Thank you for joining us and stay safe.
Okay, thank you, Sa. We are now live. Hello from my part, welcome to the Finnish Azure User Group Virtual Tips and Tricks Extravaganza to the Max 2020. Quite the mouthful there, so thanks for that. My name is Rintsi, I work for Houston Inc. as a principal architect, and today I would like to share some of my experiences during the last 18 months or so, where I have been struggling my ass off with getting something UI-wise running in an Azure IoT Edge, and also on that note, on top of Docker, with the technologies that I do know, which are web-based technologies. So a few things here and there that I picked up pieces here and pieces there and started to put something together that I thought that was cool. And I kind of ended up with choosing from hardware perspective. I was looking at Raspberry Pis and so forth, and because well, easy to access and they're cheap, and also that you can get relatively cheap touchscreen displays also to Raspberry Pi. Okay. So then comes along last summer, which is I kind of like want to set up the problem here first, that my parents live in the countryside, and with the drought that was hitting up Finland last summer, the well actually, they have a well there, and it actually dried up. So then my mother said that maybe you can do something that we wouldn't, you know, at least we would know that if the well is running out of water. So as I'm already also chairman of the board at Viro Taklavarru, and I've been tinkering with electronics and stuff for the past a couple of years as well. So so then I said that okay, maybe I can try try and do something about that. So then when I have an interesting problem, I could actually kind of see that, okay, which things I could now incorporate into making something useful for my parents as well. So yeah, so basically took out a Raspberry Pi. I have a 3B, not the Plus version, so it's only 1.2 gigahertz, but it just does have a 64-bit processor and a quad-core Cortex A53. And it supports ARM V8 instruction set, which is cool. So you can actually run 64-bit operating system on top of Raspberry Pi. Although Raspbian is 32-bit, so you need to change that. And now, actually, Ubuntu does release an ARM64 architecture version of Ubuntu 20.04. And as I haven't been using Ubuntu since 5.04, I have a little bit of experience running Ubuntu, so that's a good choice for me. So yeah, and then comes along Docker. Now the biggest, or I forgot the part now what I want to actually run in Docker. So the UI part. So what I came across a long time ago already, actually, it was Electron. Probably most know that because Atom, for example, is built on top of that project. So so yeah, you can run like bundle UIs with Electron quite nicely, and they do have a relatively good, I think, the building chains and also the packaging. So the packaging was really what I was really interested in, because I noticed that they actually support ARM packaging. So you can actually make a deb package out of Electron, and then put that package into an OS on Docker, and then run that on top of IoT Edge. So that's what I did. I did the first demos of that last year. Wrote a blog post about that as well on the HackLab context and so forth. But it was still lacking something that I didn't like. So, but yeah, so the building blocks here are Raspberry Pi, Electron app, packaging that to Docker or Debian package and put that inside the Docker, and then just use that Docker build to run your application. So let's kind of dive into that on how I approach that then on the actual implementation side. While we go through the, I think we can touch that the kind of the Docker file. So how do you actually build the application? But then I wasn't planning on doing this on this talk, but we did want to on kind of like job-related things. We wanted to have multi-platform, multi-architecture builds also for this. And actually, you can achieve this with the BuildX. That is still experimental, but for example, GitHub Actions do support a community module that you can run BuildX in the GitHub Actions workflows. So we're going to look at that as well. So so this is why the target platform is kind of here. So we want to set up our two-stage build for Docker for the actual builder first. We're targeting AMD 64 and ARM 64. So then this target platform automatically pulls the correct version of Ubuntu as the building platform, and yeah, goes from there. So we are running a Node 12 here for the installation, and then just the ordinary stuff, setting up a working directory, setting up as an environment first, and then using that environment variable as a working directory here, just because you can then reuse that environment variable here quite easily. Then where we move the package session in, do the npm install, And then there's a nifty tool called JQ, I believe that's JSON query or something like that, where you can actually just take the version out of the package JSON to be used as your application version as well. So we save that to the version.txt to be used later on. Then we have our application, put that in, and then the interesting thing with the first hurdle I kind of came up with when building this multi-architecture thing was that you introduce the platforms as Linux / AMD64 and Linux / ARM64, for example. So that's how Docker knows that which architecture is. And I'm not quite sure yet on what is. I think that's the common convention. But then also looking into the tags that Ubuntu does have in the Docker Hub, they have Linux / ARM64 / V8, and I'm not really sure how they resolve the platforms though. So I think that it's a support so that later on when you would have a version 9 instruction set, for example, so then you could just say ARM64 / V9 to be specific instruction set. But I'm not really sure about that. But anyway, so then to be able to build the Electron app, the Electron only needs only the word ARM64. So we take the Linux part out to extract the platform. So we just set out the Linux /. So we are left out with ARM64. And then there's for the second line is the architecture, because then for some reason the Electron guys have defined that when you're building the 64-bit version, you actually need to use x64. So that's why the architecture is here, to change the AMD to X, so that we get the x64 for the AMD 64-bit build for the average 60-bit architecture. Then we are running the Electron rebuild. I'll show the scripts in the package session later, but we kind of rebuild all the modules that might be in there just to make sure that we have the correct architecture. Some of the dependencies might be needed to compile from code for C bindings and such. So we rebuild those bindings. Then we actually run the actual build, and then the Debian installer. And then what I did here, I will explain the reasons later on, but I actually then move how the builder works is it takes the project name and then the version and then the architecture, and perhaps this kind of installer for or the name is crafted like this. So I move that to simple svlui.deb for our building context, so that it's then just easier to copy from here. So yeah, let's quickly take a look at the package session. What's happening here is that the rebuild doesn't need any specific flags, at least that I know. And then you have the packager. So it takes the package name. You want to override always. Then we have platform Linux, and architecture is now the architecture that was set in the Docker file into the env from the build platform. So in AMD 64 version, this would be x64 for the build part of the Electron packager, for some reason or another. Then for the Debian installer, we take the package, and then this is then the architecture that makes the actual deb package is then AMD 64 again. So there's a kind of like an inconsistency between these two, but this is how we satisfy then the when you have an AMD 64 Ubuntu, for example, and you want to install the deb package. If it does build if you put x64 here, but it just defines the architecture as x64, and it doesn't match the architecture on the target system. So it just complains that you cannot install x64 and AMD64 machine. So, but we get around that by changing this architecture to the platform. Yeah, cool. So then we have our package. Then in a multi-stage Docker file, you start with from, you set it as a set this build context. You can give it a name, and then usually you'd see like entry point or then execute the what's the other command in the end, and the CMD or something like that. But in multi-stage, you just leave it like this and start another from. So so this ends this context here. Again, we take the target platform Ubuntu 18.04 as our platform, and then we install our dependencies. As the Electron is based on Chromium, we need a couple of dependencies for the Chromium to work. So this is I found the minimum viable thing that, or the minimum libraries that you need dependencies for enabling Docker to use. Okay, this is some old testing stuff. I can actually remove that now. And for the kind of extra security things, I'm not super familiar with all the Docker security intricacies, and I'm not actually sure how this actually works. But I have an understanding that if you do a user inside the Docker container with the same UID and same group ID as the host system, and when you then use the host network, it will actually then be run as the host user instead of root user. But I'm not completely sure about if that is true. But anyway, we don't need root for anything, so we create a user and then change to that user later on. Set its home and then run the actual app. But here's the kind of the magic part. We copy the Debian package from the builder side, and then just install that package, and then we can run that as our user, and we should see our application then spin up on our device. Cool. So that's kind of that. Then I would like to quickly show you how the builds are actually. Okay, so I have to go to the fallback, it seems. I was a little bit late with my the other one is actually, well, let's see what happens. So then when you actually then want to build and push this application to Docker Hub. So I actually have that code here, so we don't have to go there yet. So yeah, so I have this workflow YAML file for BuildX. So we want to do a couple of things. I haven't really figured out the kinks out of this yet. As you saw, what I kind of wanted to do is I can't remember now where I got this from. I blame myself for not getting the source. So whoever did this, thank you very much. I will deliver that information later on. Maybe we can put it in the descriptions to give credit where credit's due. But basically, you want this script does three things. It builds on schedule, so we can kind of get nightly builds or daily builds or what are you going to call them, and then it does build on pull request just to see that the build actually goes through, but it doesn't push it, and then we push from master branch when we have, and also when we have version tags. This is a little bit, I haven't read too much on the documentation side, so I have to figure this part out. So which part does which thing, but anyway, going on to the BuildX part, I'm gonna just check out our repo and then prepare our environment. So we define our Docker image where we want to push it. We define the platforms, so we are targeting AMD64 and ARM64, and we set the default version as Edge. So if you just push to the master, it will build the Edge version. So we will now shortly see if this actually worked. So whether it built our tagged version or release version. So what this should do is when you tag with version, it sets the version to be what was in the tag, and then push that into Docker Hub. And then finally, if we have the schedule one that was defined here with cron, for the nightly piece, it sets the version to be nightly, and then sets the appropriate tags, outputs the stuff that we need, and and then sets up the build-x environment. Then we actually do the builds. So it's super easy with build-x, or it seems to be when it works. Just finding out how reliable this build stuff actually is, but it seems to be quite good. So it's just output what you want, and then put up the tags and set up the platforms that you want to build, and it will build them in parallel, and also taking account in the multi-stage. So it starts to build both stages, and when it cannot proceed anymore, it waits for the other stage and so forth. Then we do Docker login. And then finally, if we have a success and it's not a pull request, we do the push. And then it checks some kind of manifest stuff, which is needed then for the Docker Hub. But now let's go and see what happened to. Oh yeah, I just realized I had a wrong. The wrong plans, but anyway, let's move forward. Or maybe, well, should we take a recheck here? So just quickly, again, what I was talking about before. Sorry about this. I'm new to OBS, so forgive me. This is my first time being live. So yeah, so what I wanted to do is the nightly builds. We do actions on pull requests, and then we push on when we have a release, basically. And yeah, so and this is what I was talking about with the platforms. So here is where we define those, the default versions, Edge, and yeah, this outputs then all the parameters for the build-x environment. We install, set up that. It's from CrazyMax. Oh yeah, here you can then find the where I actually got this from. So the CrazyMax action Docker build-x module, or GitHub action rather. So it just then outputs the build-x arguments, and we build, we Docker login, we push if we don't have pull request, and then we check for the manifest stuff. So quick thing to go there. And now we go back to the browser. So too many things. So yeah, so it seems that my latest commit that I did, where I tagged my release for the 0.5.4, did build the tag, but not the edge, sort of. So maybe we can now take a look at what actually happened on the Docker Hub side, whether it actually got built now. So there's something that probably the version is not parsed correctly inside the action, so I need to take a look at that. But yeah, so the edge was deployed 17 minutes ago, and yeah. So now then, what I like to so kind of few words then. If you take a look at the deployment considerations, kind of so I think that most of you, if you've done something with IoT Edge, you might be familiar with the tools that come with VS Code, where you create the solution and create the modules and stuff. So this is basically what it then looks like once it comes out of there. So you have your deployment templates, and then you have your config, and then you would have a modules directory which contains then your modules and so what you would have your Docker files there. So so my recently I have been trying to figure out on how to kind of break that when you are making modules that work together, but I want to handle those as a separate things and not to have this monolith, but just to have those in a separate GitHub repositories in order to make open source stuff, for example, and then kind of combine those into a deployment where I combine those modules and then deploy them. So that's why I created this is basically what you have then on the solution side, and then this is extracted from that to be just the module in itself, and I can work with this module inside GitHub and build it and put it to Docker Hub. And then I actually then have the actual deployment template where I define that what I want to run. So then you have your agent, your hub, and your configurations, and then you have your modules. So then I have defined here the well UI module, and I have a couple of environment variables here for making sure that we have the correct display, screen widths and heights to be when we target multiple devices. And then we have our image. So then in here you'd have your dollar thing, your modules dot sting, which then just refers to the directory you have inside the module directory. So you can kind of refer your own module on your local host. But you can, of course, always then use your own module that is deployed to Docker, which is what I tried to do. Which I actually did do, but yeah. Now let's see if we have a demo effect. I think that we don't have time to actual, so I need to adjust the demo a little bit. But then one important consideration that I battled with a lot when I first tried to get this thing working. When you run Electron and it's inside it's running Chromium, then the way how Chromium uses shared memory is for the rendering of the web page. So when you want to display something on the actual display, or render something rather on the display, you need to share the memory with the what it was called. The IPC is the interprocess communication. It's a POSIX standard thing for. It's a nameset that provides separation of named shared memory segments, semaphores, and message queues. So kind of like how the processes talk with each other, and this is how apparently the rendering talks. So I need to set that to host in order to the Electron app to render at all. If you don't have this, the application will run. You will have a white screen, and all what is quirky enough is that all the actions, if you have clickable items or touch items, they actually work. You can interact with the application. It just doesn't render. Yeah, and then I'm not sure. I didn't have time to try to run without the network mode host. Basically, said that if you want to use Bluetooth, for example, from the container, you need this to get access to the because Bluetooth is like in the network, same network stack. So you need to have the host network enabled, and then you kind of need this container to be privileged to be able to access these things. But I think that this works then together with the user that we made. It actually then is a little bit more secure. So yeah, and then you would when you have this deployment template, you can just set your default target platform by edge solution. I'm not sure nowadays, but a few moments ago you needed to install an additional plugin to enable the ARM64 V8. I'm not sure if it now comes in with the package, but I think that is information you can find quite easily. But you can now then set the default platform, and then just right click and generate the deployment manifest, which will then create the deployment manifest under config. And then what you can do is create deployment for a single device if you want to try. I will take my device here, and it says that deployment succeeded. So this will then go to IoT Hub, set the device name or the modules there. The runtime will connect to with the cloud and say, okay, yeah, I need to update my container. It downloads the container and runs it on the actual device. So yeah. So let's see now. I think that I need to adjust my demo a little bit because I'm now looking at the blank screen on my Raspberry Pi because my build failed. So what I can do is that I will run the application locally. And that I can actually do by calling. And this is a cool thing now. I'm running WSL2, and with X410 that you can get from Microsoft Store, you can actually install an X Windows system on Windows. So you can actually run graphical applications from Linux side onto Windows. So as I have my Electron here, which is now built on the Ubuntu, running WSL, I can then just run my Electron app here. And I will quickly switch this to window capture. Electron. And take this. Okay. So this is the application that I made. Just to quickly show, it should be now running on the Edge device, but I have a tendency of making things, that I shouldn't do before demo time. So, but the kind of basic idea, of course, is that I like to have this what's it doing? Okay, that's fine like that. So so yeah, basically I wanted to have the depth on the right side showing that, okay, what's the current situation, and then the last 7 days is a trend, so you could see where it's going. And yeah, I did some SVG animation stuff to demonstrate that what can you then do when you're running an Electron app, because you can do all the web stuff then in the user interface. So it gives really that's much more to the actual design of the application to be able to use the web way of thinking that make an actual kind of like a web application instead of having to do native user interfaces, which kind of can look a little bit too much engineered in my opinion. And then what you can kind of do with the whole kind of animations and stuff, and they become quite fluid experiences with Electron, especially if you have a GPU, for example. We are looking into the NVIDIA Jetson Nano tool. We have the dev kits and stuff, and it runs CUDA. So I'm not yet sure if Electron or Chromium supports that or through Docker or not, but you could possibly run WebGL stuff on the browser inside a container that actually uses the CUDA stuff. So yeah. So them parts were not with me today. But yeah, that's this was supposed to be that part. But yeah, thank you for that. I will stay here also to answer any questions that you might have. You can leave them in the chat. But before we go to that section, I just want to give a shout out to the next presenter, who is Pasi Huuhka, talking about security stuff for the app services, which will be, I think, very interesting. I will most likely want to see that and not want to miss that. So yeah, but yeah, go to that one. It's on the 17th of June at 2 o'clock finish time. And now we can take the QA stuff. Yeah. So immediately first question with the blog post. Yeah, I'm working with the revised version for that blog post. That's somewhat outdated. Mostly, the biggest thing there is that I wasn't running then the application on the Edge runtime. Now I do. Kind of like figuring out that how the shared memory stuff worked, and what was the reason behind it didn't render. And then another thing was that when you install the Ubuntu ARM64 version, it's actually a server version. So you burn that into the SD card, you can run that, but then it doesn't have a Windows system, so or display manager. So basically, you just install ectorg. And what I found at a good lightweight display manager is LightDM, and companion with this greeter. I believe it was called auto-locking greeter or something like that. When you configure that, you can just say that what user you want to auto-log in when the machine boots, and then it logs in automatically. And then the cool way is that it actually can then run basically on a kiosk mode, where when the IoT Edge runtime kicks in, if you have the module set up to be run, it launches the module, and when it goes to full screen mode, you can't actually do anything else with the user interface or touching the underlying operating system. Yeah, the authentication to the Docker Hub on the devices. The image is public, yes. So at the moment, there's kind of nothing that will touch that. But what I plan to do then next, and what I didn't talk about now, is that I have a Arduino Uno with they don't make this anymore, but this is a Libelium 420 milliamp. So basically RSH 485 standard thing, where you can then run sensors on. And I have this industry pressure sensor that I tested with this to be put inside the well. And this will talk through serial connection then to the user interface. So I plan to decouple these and make an IoT Edge module of that part, just accessing the serial connection and putting that data into the internal route of IoT Edge runtime, and then just having that user interface to listen to that, and maybe another module that pushes the values upstream to be saved in a database, so that I can then query it back into the chart to display trends. But then how IoT runtime works and the security, if I understood your question correctly, is that when you have the Edge runtime set up, you can actually then run the module client, which will use the internal Edge runtime's internal security daemon to query the connection string to the IoT hub. So then you can actually, in that part, also release your code totally free from accidentally putting connection strings or something in there, but it will use the underlying runtime to resolve the connection security issues. And what I'm kind of planning to do is to, as we do commercial stuff also at the moment regarding IoT Edge, we have this module that we're working on, which you can ask certificates to be made from enrollment groups to to be put inside the device to make certificate-based authentication rather than connection string based. So then you just put the certificates into the card and set up the runtime environment to use the certificate-based authentication, and yeah. So just yeah, to make it a little bit more secure than just using the connection string. I guess Azure IT Central. I'm not too familiar with Azure IT Central. I'm the kind of guy that when I'm also a front-end developer, or I have been for a long time. So I like to make my own user interfaces, even though it's something that everybody shouldn't do. But yeah, I like to experiment with stuff. So cool. So I think that just wait. I think that if there was no questions coming up to well, kind of these were the questions, and now I'm seeing thank you. So I think that this concludes our live session today. Thank you for participating to the Mouthful Finnish Azure User Group Virtual Tips and Tricks Extravaganza to the next 2020, and make sure you catch Pasi's next presentation on the 17th. So thank you.